Have you ever wondered how a completely random, creative thought actually turns into hard scientific fact? Well, the scientific method actually leaves a whole lot of room for creativity when it comes to forming our initial research questions. But once we have that question, we can't just rely on our gut feelings, right? We have to test it methodically. So today, in this explainer, we are exploring the empirical cycle. It's absolutely the best framework out there for combining systematic observation and logic to test our hypotheses about how the world really works.
Okay, let's dive into this. Here is our agenda for today. 1. The big picture. 2. Observation and induction. 3. Deduction and the setup. 4. Testing the prediction. And 5. Evaluation and repetition.
Section 1. The big picture. Let's frame the problem.
So here is the fundamental question we are trying to answer. How do we systematically prove how the world works? Because we all have theories, right? You probably have a theory about why your favorite sports team keeps losing, or why the line at the grocery store always seems to slow down the exact second you join it. But how do we take those creative research questions and actually test them methodically without letting our own personal biases get in the way? Well, the empirical cycle captures what scientists call the hypothetico-deductive approach. I know, big word, but it basically characterizes the whole process of generating hypotheses about how stuff works and then rigorously testing them against empirical data. Being familiar with the 5 phases of this cycle acts as our overarching roadmap today, and it's absolutely crucial for keeping the big picture in mind whenever you're analyzing new information.
Moving on to Section 2, Observation and Induction. We start, naturally enough, with the observation phase. This is really where the magic happens. It's where a simple observation sparks the idea for a brand new research hypothesis. You might observe an intriguing pattern, or maybe an unexpected event happens. Really, it's anything that you find interesting and want to explain. And honestly, how we make this observation doesn't matter at all. It can be a personal observation, an experience a friend shares with you, an imaginary scenario you cooked up in your head, or previous systematic research findings. Anything goes at this stage.
Let's look at a highly relatable, kind of funny, real-world example from our source material. Imagine a researcher makes a personal observation. I have a horrible mother-in-law. Then they go and talk to some friends, and it turns out those friends also complain about their mothers-in-law. Suddenly, this really interesting pattern begins to emerge. It's a pattern between a specific type of person and their general likability.
And that totally unexpected pattern leads us right into the induction phase. Here, the relation we just observed in a few specific instances is turned into a general rule. That's exactly what inductive reasoning is. Taking a statement that happens to be true in a few specific cases and inferring that the statement must be true in all cases, always. We are basically transforming specific observations into a broad, general hypothesis.
So, from the observation that the researcher and their friends have horrible mothers-in-law, we can induce this grand general rule. All mothers-in-law are horrible. Now, it is incredibly important to remember that this rule, this newly minted hypothesis, is not necessarily true yet. I mean, it could be completely wrong. And that is exactly what the rest of the cycle is built for, systematically testing this bold hypothesis.
Section 3, Deduction and the Setup. And this brilliantly illustrates the difference between these two concepts. While induction took us from a few specific instances up to a broad general rule, deduction completely flips the script. With deduction, we deduce that our general rule should hold up when applied to brand new, entirely untested specific instances.
So in the deduction phase, deductive reasoning transforms our broad hypothesis into a really explicit expectation or prediction about new empirical observations. We basically need a concrete prediction that we can actually go out into the real world and measure. Returning to our mother-in-law example, if our general rule that all mothers-in-law are horrible is actually true, then we can make a very specific prediction. If we ask 10 random colleagues to rate their mother-in-law as either likable, neutral, or horrible, then they should all, literally every single one of them, choose the category horrible. But wait, before we can just start interviewing those colleagues, we have to determine our research setup. We have to clearly define our relevant concepts, like what exactly constitutes likable, or neutral, or horrible. We need to establish our measurement instruments, our exact procedures, and the specific sample of people we're going to collect data from. The deduction phase isn't just about making the prediction, it's about the detailed specification of the entire research setup.
Section 4. Testing the prediction.
All right, we are now in the testing phase. Here, the hypothesis is finally put to the test by collecting new empirical data and comparing that data directly back to our prediction.
Now, usually, this phase requires some statistical processing. We rely on descriptive statistics to summarize all those raw observations for us, and we use inferential statistics to help us definitively decide if our prediction was correct or not.
Now, what's really interesting about this slide is the actual data we collected from our 10 colleagues in this simple example. Honestly, we don't even need complex statistics here. We surveyed the 10 colleagues, and the results are in. 8 out of 10 rated their mother-in-law as horrible, but 2 rated her as neutral.
And because of those 2 neutral ratings, we can see right away that our prediction did not come true. It was refuted. Our explicit prediction was that all 10 mothers-in-law should have been rated as horrible. Because that didn't happen, our testing phase has officially disconfirmed the prediction.
Section 5. Evaluation and repetition. We now enter the evaluation phase, which is where we interpret our results in terms of our original hypothesis. Now, it is incredibly important to note that even if a prediction is confirmed, it only ever provides provisional support for a hypothesis. It never means we've definitively proven it forever. Why? Well, because it's always possible that somewhere in the future, we'll find a single person who just absolutely loves their mother-in-law, which would instantly break the absolute rule. But in our specific example, the prediction was entirely refuted. So does this mean we just throw the whole hypothesis away completely? Not necessarily. There are often very plausible explanations for a failure to confirm. If we think the issue was just a flawed research setup, we might preserve the hypothesis and investigate it all over again with a better design. Or we might adjust the hypothesis based on the new results. So maybe most mothers-in-law are horrible instead of all. Rejecting and discarding a hypothesis outright actually only happens in very rare cases.
Let's move to and see how this builds right back into our overarching cycle. The observations we collected in the testing phase, like those 2 colleagues who felt neutral, now serve as brand new specific observations back in the very first phase. This is exactly why it's a cycle. The new empirical data obtained during testing gives rise to new insights, which lead to a whole new run-through of the entire thing.
And honestly, that is what empirical science fundamentally comes down to. We systematically observe a pattern, we induce a general rule, we deduce a testable prediction, we test it with hard data, and we evaluate and repeat. We do this again and again and again, trying to hone in on the absolute best hypotheses to build our collective understanding of the world. So, the next time you notice a weird pattern in your daily life, don't just blindly accept it as fact. Ask yourself, what everyday observation will you run through the empirical cycle next? How will you systematically test it? I really hope this explainer has empowered you to look at your world just a little more methodically. Keep observing, keep testing, and as always, stay curious.